Alrighty, it is time for some video learning, kids. Today we're going to talk about plotting points and lines and about the coordinate plane. So, what is the coordinate plane? Coordinate plane is, and I'm sorry, I couldn't find any good pictures of this, so you're going to have to deal with my hand-drawn one. So, we have the coordinate plane. This is our x-axis. This is our y-axis. This center point right here is, hold on, 0, 0, and it's called the origin. Origin. Alright. So let's talk about this coordinate plane. You can see that it is set up in 4 quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. And notice we use Roman numerals because they're cool. So, quadrant 1. Well, first of all, let's figure out where do we have our positives and where do we have our negatives. So, our positive is, for the x-axis, it's positive to the right. It's negative to the left of the y-axis. The y-axis is positive up, and it's negative below the x-axis. So when we have an ordered pair, and an ordered pair is our x and our y. And that's a comma. It's a big old fat comma. This is an ordered pair. Let's see if I can write that. Nope. Forget it. That's an ordered pair. So, in this first quadrant, both the x and the y are positive. Let me redo that because I said what I meant to write and I wrote something different. The x and the y are both positive. In this quadrant, the second quadrant, our x is negative and our y is positive. And if you want to try to remember a good way to remember what comes first is it's alphabetical. X comes before y in the alphabet, and that's the same deal with the ordered pairs. In the third quadrant, well, they're both negative. Both our x and our y is negative. And in the fourth quadrant, we have positive x, negative y. So, with that information, let's say that I wanted to plot a point, and the point I wanted to plot was, I really don't like this stylus. The point that I wanted to plot was 3, negative 2. Alright, well our x is positive, that's positive, and our y is negative. So it'll be, let's see, our positive, negative, so it's going to be over in the fourth quadrant. So I'm going to go over 3, 1, 2, 3, and down to 1, 2. So I go over 3, down 2, and there's the point 3, negative 2. So, graphing a function. The first thing we want to do, this is step by step, you want to solve for y, which means I want to get y by itself. So, when I have this ready to make the table, I'm going to be in a format of, hold on, I'm going to be in a format of y equals. Hold on a second. I need to go see if I can make my own stylus that actually works better. Okay, so now I have a super cool homemade stylus. Check this out. Hold on. Alright, well that's not going to erase. So, Solve for y. What I mean by that is you want to get y by itself. So it would be something along the lines of, y equals 3x plus 2. So y is by itself on one side of the equal sign. Then you make a table, and a table, I mean a t-table, an xy table. Isn't this a cool stylus? I just made it. It's a pen and it's a pen and aluminum foil. Then you plot the points on a coordinate plane. So for example, y equals 2x minus 1. Okay, well, number 1, get y by itself. Oh, check it out. It's already by itself. Number 2, make a table. So I have x and I have y. And I'm going to say x equals negative 2, negative 1, 0, 1, 2. So to figure out what y is, I plug in these values of x into this equation and solve for y. So it'll be 2 times negative 2 minus 1. So 2 times negative 2 is negative 4, minus 1 is negative 5. Plug in negative 1, so I have 2 times negative 1 minus 1. Well, 2 times negative 1 is negative 2, minus 1 is negative 3. This third one, plug in 0 for x. 2 times 0 minus 1 is 0 minus 1, or negative 1. Plug in 1 for x. 2 times 1 is 2. 2 minus 1 is 1. And then I'm going to plug in 2 for x. So 2 times 2 is 4. 4 minus 1 is 3. Okay, I've got my points. So my first point, well, I'm going to draw an xy coordinate system. And again, you have to bear with my drawings. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. They're not very exact, but they'll work. So this is 5. This is negative 5. Whoops. This is 5. This is 5, and this is negative 5. All right, so my first point, when x is negative 2, y is negative 5. I go over 2, down 5, plot a point. When x is negative 1, y is negative 3, so I go over 1, and I go down 3. Notice I'm going in the negative direction for x and the negative direction for y right now, because those are my points. When x is 0, y is negative 1. So x is 0 is right here on the origin. Excuse me. And again, okay. So 0, negative 1. When x is 1, y is 1. I go, excuse me again. I go over 1, up 1. And then when x is 2, y is 3, so I go over to the right 2, and I go up 3. And there is my function. Okay, so let's talk about graphing linear equations and functions. So an example of a linear equation would be something along this lines. 2x plus 5y equals 8. So each linear equation has many ordered pairs, or values for x and y, that make this equation true. So here I've got this all scribbled out because I wrote it wrong. So my question is the point 1, negative 4 a solution to 3x minus y equals 7? Alright, well, looking at my ordered pair, I know that my x value is first, so x equals 1, and my y value is second, so y equals negative 4. What I'm going to do is I'm going to plug in these values into this x and this y and see if it's true. So 3 times 1 minus negative 4 equals 7. 3 times 1 is 3 minus a negative 4 equals 7. Well, subtracting a negative is just like adding, so it's like adding, so 3 plus 4. So 7 equals 7. That indeed is a solution. Let's take a look. Same equation right here. 3x minus y equals 7. What is about the point 2, negative 1? Does that work? So x equals 2. Y equals negative 1. So I'm going to plug in my values for x and y. So 3 times 2 minus negative 1 equals 7. Well, 3 times 2 is 6. 6 minus negative 1, does that equal 7? Well, subtracting a negative is just like a big old addition. So 6 plus 1, 7 does indeed equal 7. So check. Graphing lines. Okay. Pretty much the same thing that we just went through before. Solve for y, make a table, plot points, connect the points. So here's my example. Negative 2x plus y equals negative 3. So to solve for y, I want to get y all by itself. So that means I'm going to move this from this side of the equation over here. And I can't do that by magic. I have to do it by algebra. So to undo it, I've got minus 2x. I'm going to add 2x to both sides. These cancel, and I get y equals. Now I can't mush 3 and 2x together because they're not like terms. So I just have to write them both out. 2x minus 3. Okay, there's my equation. Y equals 2x minus 3. Let's make a table. So I have x and y. So let's do negative 2, negative 1, 0, 1. So same deal as we did before. I'm going to plug in these values right here of x into x here and solve my equation for y. So if I do 2 times negative 2 minus 3, I have negative 4 minus 3 equals negative 7. If I plug in a negative 1, I have 2 times negative 1 minus 3. Well, 2 times negative 1 is negative 2, minus 3 is negative 5. If I plug in a 0, I have 2 times 0 minus 3 equals negative 3. And finally, I plug in a 1. 2 times 1 is 2 minus 3 is negative 1. Okay, so if I plotted this on my handy hand-drawn XY coordinate system, let's see, 1, 2, 3, 4, 5, 6, 7, that just barely reaches. And I'm going to have 1, 2, 3, 4. 1, 2, 3, 4. And I am just coming up with like random, or I'm not coming up with completely random, but I'm just putting enough tick marks on so I can graph this. So when x is negative 2, y is negative 7. I go over 1, 2. I go down 7. It's right there. When x is negative 1, y is negative 5. It's right about there. And these aren't going to be exact because of my hand-drawn coordinate graph and also my cool stylus. When x is 0, y is negative 3. Right, oh shoot, right there. When x is 1, y is negative 3. So there are my points. And now the fourth line, I'm going to connect the dots. Okay. The last thing I want to talk about are horizontal and vertical lines. Horizontal line, vertical line. So when y equals 2, y always, ooh, that's a bad axis. Y always equals 2. So this is x, this is y. Well, where does y equal 2? 1, 2, right there. So I'm going to have a line, a horizontal line, that goes through at y equals 2. And then x equals negative 1. This is x. This is y. I've got negative 1, negative 2, 1, 2, whoops, negative 1, negative 2, 1, 2. All right. Where is x equal to negative 1? It's right here. So I'm going to have a line that goes through negative 1 always. So, when y equals b, where b is a constant, and by a constant I mean just a number, you have a horizontal line, just like we did here. Our b was 2. I had a horizontal line through y equals 2. When x equals a, where a is a constant, you have a vertical line through x equals a. Same deal here. My a was negative 1. and I had a vertical line through x equals -1. So that's how you draw horizontal and vertical lines. Okay, so tonight and for class, I want you to try on your own. I want you to plot -3, 2 on a coordinate plane. I want you to graph the line y equals x plus 4, graph the line y equals -2, and graph the line x equals 4. Good luck, and I will see you in class tomorrow.